When you see the term electron configuration, that means we are considering where electrons are in an atom. And where electrons are in an atom determines the reactivity of an atom. So we really care a lot about that. Now, as scientists began to delve into the structure of the atom and understand electrons a little bit more clearly, it became evident that electrons are unlike any type of matter that we had previously studied. So a whole new realm of physics had to be developed to describe electrons, and that physics is known as quantum mechanics. We're not going to go into quantum mechanics in any type of detail, but we are going to pull some of the simpler aspects of quantum mechanics out to understand atom reactivity. And we're going to use what's known as a shell model, which is based on the quantum mechanic physics, but just not as complex. So when we talk about the shell model, what we mean is each atom has energy levels, known as shells, that are designated by whole numbers. So the shell can be the first shell, second shell, third shell, fourth, fifth, sixth, and seventh. And electron stability depends on those electrons being in the lowest energy shell that they can be. So the energy level of the shell increases as the number increases. So if we look at this slide and look at the nucleus for hydrogen, which has one proton, and therefore it has a positive one charge. We see the circle represents that first shell. We would use a second circle to represent the second shell, and then another circle to represent the third shell. And each shell gets further and further from the nucleus. Now, electrons, which have a negative charge, are attracted to protons, which have a positive charge. So electrons want to be as close to the nucleus as they can. All right, now let's look at the maximum electron capacity in each shell. So electrons want to be as close to the nucleus as they can, but once a shell becomes filled, then they have to go to the next shell, which is further away from the nucleus. So the first shell can hold 2 electrons. So on the slide, we see the 1 electron in hydrogen is in that first shell, and then helium has 2 electrons, and it's also in that first shell. So how does this relate to reactivity? Well, filled shells mean that an atom is not reactive, and unfilled shells means an element is reactive. So if we look at the periodic table, hydrogen with 1 electron is reactive because its first shell is not filled, whereas helium has a filled first shell, and so it is not reactive. Hydrogen is reactive, unfilled shell. Helium is not reactive, filled shell. So if we look at the second shell, it has a maximum electron capacity of 8 electrons. So in the second shell, that starts getting filled in the second period, where we have 3 electrons. So now we've filled the first shell, we got to go on to the second shell. 1, 2, 3, 4, 5, 6, 7, 8. Neon has a filled second shell, so it is stable. Every other element in the second period does not have a filled shell, and so those atoms are going to be reactive. In the third shell can actually hold 18 electrons, but we're going to look at 8 as the maximum capacity because that refers to the third period elements which are biologically relevant. So argon has a filled third shell, 1, 2, 3, 4, 5, 6, 7, 8. So it is not reactive, but every other atom in that third period has an unfilled shell, so it is going to be reactive.